Okay, so our second derivative is taking the derivative of a derivative. The notation, first derivative is dy dx, y prime or f prime of x. Second derivative is d2y dx squared, or y double prime or f double prime. If we're taking the third derivative, it's or higher. You don't keep putting primes because that's just going to get messy. Alright? But any higher derivative, third, fourth, fifth, or whatever, you do dny dx to the n, or y, and then you put, to differentiate, this is important, put it in parentheses so that you know it's not a y cubed. Okay? So you would do y3. Okay.
Yes.
Thank you so much. I'm sorry again. So here, if I'm doing the third derivative, I would have d3y dx to the third, or y triple prime, you could say, or the third derivative of f of x. Okay, so and that applies for any number bigger than 2. Don't use the primes slashes for anything more than 2. Okay. So basically, what I want to do is I want to run through a couple of examples, and then really it's just a matter of applying the rules we've already learned. Okay, in order to do this, you just have to be careful as you go from step to step because the rules you're going to use may differ as you go from step to step. Okay, so for example, let's say we want to find the third derivative for f of x equal to x cubed minus 5x squared plus 4x minus 10. Alright, now this is what we would call a recursive process. There's no way to get the third derivative without finding the second one, and there's no way to find the second derivative without finding the first derivative. Okay, so you have to kind of do this recursive process. Go all the way back to the beginning. Thank you. Go all the way back to the beginning and find every one until you get to the derivative you're looking for. Alright, so first of all, we'll find f prime of x. And since this is a polynomial, it's relatively simple. We've got 3x squared minus 10x plus 4. Okay? Then we'll find our second derivative, so f double prime of x, and now we're taking the derivative of our first derivative. So first derivative is 3x squared minus 10x plus 4, so our second derivative would be, very good, 6x minus 10. Alright, now our third derivative would equal 6. Okay? If we went one more and did a fourth derivative, we'd be at 0. And then every derivative after that would be 0 as well.
Is there a word for that? Like the degree of derivative right before you hit zeros?
I'm not sure. I haven't heard one before. Okay. So you notice here, our velocity is quadratic. It's going to increase and decrease and so on. Our acceleration, we said acceleration was the second derivative because it's a rate of change of the velocity. Our acceleration is actually going to be constant.
I think it makes something up.
Linear.
It should be 3x squared minus f plus 4. Actually.
3x squared minus 10x plus 4.
Oh, never mind.
Okay. Now, think about this and what this would look like. This is our acceleration is constant, okay? This was a cubic, this was a quadratic, this is a linear, and now we have a constant for that third derivative.
So the red one's acceleration.
Yes, that would be our acceleration.
What's the third one?
The third one, I think it's called the jerk. So, I'm not sure what, I'm not 100% positive. I know it's either the third or the fourth one. So, alright, so that's relatively simple. So then if we wanted to find, the third derivative of f at x equals 2, at this point, we could plug in 2, it's still going to be 6. Alright? Now let's look at one that gets a little bit more complicated. Here we have y equals tangent of x cubed. Let's real quickly write down our trig function derivatives, just as a matter of review. You didn't have to memorize all these, but let's see how many you remember, okay? The derivative of sine, this will wake up. The derivative of sine is cosine. The derivative of cosine is negative sine. Do you remember what the derivative of tangent?
Secant squared.
Secant squared, good. I'm not sure what happened there, but oh well. Alright, so sine is cosine. Derivative of cosine is negative sine. Derivative of tangent is secant squared. And just since we might need some later on, I'll keep going down. The derivative of cosecant, anyone remember that one?
Cosecant times cotangent.
Good, and it's a cos, so it's negative. Good, cosecant, cotangent. Okay? The derivative of secant,
Secant times tangent.
secant times tangent. And the derivative of cotangent.
Negative cosecant squared.
There we go, negative cosecant squared. Now, we may or may not use all of these in this particular problem, but it's not a bad thing to review. And look at that, you guys memorized these without even trying. I had to tell you you don't have to memorize things more often. So, we've gotten these as a reference over here to the side. Alright, so let's look at finding the third derivative of tangent of x cubed. Alright, so first of all, let's find dy dx for tangent of x cubed. What are we going to have to use? The chain rule. Okay, so the outer function here is tangent, so the derivative there is secant squared. So we're doing secant squared of the same thing. It's still an x cubed here.
Times 2x, 3x squared.
Good, times a 3x squared. There's our chain rule. Okay. Now, you can see it's going to get a little more complicated. Because now we're having to use the product and chain rule. Thanks. Okay? So, let's work through this one. d2y dx squared. Our u is going to be the 3x squared. Our v is the secant squared x cubed. Alright, so let's work through this. U prime is going to be 6x. Our v prime, we're actually going to have to kind of use the chain rule twice. Because we have 3 functions involved here. Alright, the outermost function is something squared. Right?
It's secant x cubed squared.
Okay, we have 2 secant to the first now of x cubed. Alright? Now we've got to do the next innermost function, which is
X cubed.
secant of x, the secant. Okay, the squared is on the outside, then the secant. So what's the derivative of secant? Secant times tangent. So it's secant, and notice what's inside stays the same. So it's secant of x cubed, tangent of x cubed. Now we have the chain rule again,
3x squared.
times the 3x squared. Okay? So these get fun really fast.
You all multiply? Like,
And it's all multiplication because it's the chain rule. So you're just multiplying those together. Okay? Essentially what you are seeing it as, if it helps you to rewrite it this way, you could. It was secant of x cubed, and then that thing was being squared. You could have rewritten the v like that. That may have helped you see the outermost function, the middle function, the innermost function. Okay? So now, simplifying this will be helpful. Okay? So I'm going to put the 2 with the 3x squared, 6x squared, secant squared of x cubed.
Wait, how you do?
I put together the 2 with the 3x squared, because it's all multiplication. So I made that the 6x squared. I put my 2 secants of x cubed together, so it's a secant squared. And then I've got that tangent of x cubed as well. Okay? So, now I have to do u prime times v secant squared of x cubed plus u 3x squared times the v prime that we just found. 6x squared times secant of x cubed times tangent of x cubed. Okay? And this is where simplifying more than you may have been required to in the past could be helpful. Alright? You'll notice both terms have a 6x and both have a secant squared of x cubed. So what I would do here is I would pull out a 6x secant squared of x cubed, and then that's going to be multiplied by what's left here? A 1 plus, we have a 3x cubed, because we only took out one of those x's on the 6x squared, times tangent of x cubed. Okay? And you know what I think I'm going to do, because I think you're getting the idea here. I think we're just going to find the second derivative. Okay? Because if we found the third derivative, we could do it, but it would take a while, because
Does that say 3x cubed?
Here?
Yeah,
Yes.
is that how you would leave it?
I would leave it like that. Yeah, that's about as simple as you're gonna get it. If I wanted to actually find the third derivative, I'd have to use the product rule here and the product rule again. And I'd have to use the chain rule a few times in there as well, and
Nice.
I'd be using the product rule, let's see, 3 times. And I'd be using the chain rule, I don't know, like 6 times or something. Yes?
Why is it 3x cubed and not squared?
I took out a 6x, but this was a 6x squared here.
Oh, so you're multiplying that x times the
So
3x.
yeah, I put that leftover x with the 3x squared.
Oh, okay.
Yeah. Okay? So it gets complicated sometimes. Sometimes it gets simpler, sometimes it gets more complicated. Either way, it's just a matter of applying the rules that you've learned to new situations. Okay? And every one is a little unique. Okay? I gave you a few to try. Some of these, you're finding a second derivative. Here you're finding a second derivative. Okay. Here you're actually evaluating the different derivatives. One thing though, remember, you don't start to evaluate until after you've found the derivative. There were some people earlier who were plugging numbers in and then taking the derivative, and of course you had a constant. So you take the derivative of a constant and you get a 0. And then there are some others here that are good IB style questions. Number 5 is kind of previewing what we're going to be doing moving forward here. Or look at this starting Thursday. F double prime of x equals 0. We're doing all kinds of higher level derivatives now, but we're going to focus in here as we go through the rest of chapter 16 on that second derivative, because that's going to give us another point and another feature on our graph. Okay? Alright, have a great day.